Okay, part 2 here will be going the other way. As soon as you see an ic acid, you look over here. If there's no hydro, then this is going to be an oxy acid. So an ic acid is an oxy acid. So I need to look up the polyatomic ion. So in this case, it's phosphoric acid. Ics and ates go together. So I'm looking for phosphorate, or in this case, phosphate. Phosphate is PO4 3 minus. The only way to find that, look it up. If it's an acid, the only thing over here to balance it has got to be hydrogens. If I have 3 negatives and each hydrogen is positive, I need 3 positive hydrogens. We don't leave this charge up here because it's gone, because it's balanced by those 3 hydrogens. And we always have to remember that an acid is going to be dissolved in water. So we get H3PO4 aqueous is phosphoric acid, which was based on phosphate being balanced with hydrogen dissolved in water. If I have an ic acid, but I do have a hydro, that tells me that it's going to be hydrogen and whatever else. In this case, it's brom, which would be for bromo or bromine. So we're looking for bromine. Bromine is 1 minus because it's in group 7, so it gets 1 minus. This is 1 plus, so that works out just fine. Don't forget that it has to be dissolved in water. So I have hydrobromic acid. If I have an us acid, it's exactly the same as an ic acid. This is an oxy acid as well. It's got a polyatomic ion. So in this case, I have to go here. But the confusing part for most people would be this little thing. That's not hydro, that's hypo. Well, hypo, us acid, just tells me something about the number of oxygens here. So I'm going to kind of ignore the us. I'm going to ignore the hypo. I'm just going to look at this iode part. It's actually iodo. This O comes with there, but that's a little trick. I'm going to look for iodate. Iodate is IO3 1 minus. I just looked that up on the periodic polyatomic ions chart. But this is not ic acid. If this was an ic acid, this would be fine. This is an us acid, and so what I need to do is I don't have the full complement of hydrogens. We have, let's go over here, 8 ite hypo ites, and way up top is a per 8. So this is the normal number of oxygens, IO3 in this case. Ite would be lower, so it would have 2. Hypoite would only have 1. So IO 1 minus is hypo-IO, in this case iodite. Ites become us acids, and so this ITE would become that OUS, and I would end up with hypoiodous acid. So this is what my anion is. I can only balance it with H's. Whoops, I should go back to red. Actually, I should go to eraser because I don't need this 1 minus anymore. So I would end up with HIO, but I gotta remember aqueous. Aqueous. Because I looked up the iodate, had 3 oxygens, and in order to get down to hypoite, I had to remove 2, which got me to HIO, aqueous. The other way is the same thing. We'll just stick with iodate since we already found it. Iodate had 3. Per iodate would then have 4. So I know that wow, that was terrible. I apologize. Per iodic acid, this iode has to do with iodate, but per iodate is 4, so I would have IO4, and 1 minus here needs a 1H plus to balance there. Per iodic acid would be HIO4 aqueous. Now, with that in mind, don't save. What do you think this might be? There's one there. This one's right here. We have our peroiodates there. Just as a little side note, whenever we kind of do organic chemistry, every one of the vertices of something would be a carbon. We don't typically do that. We just kind of draw connections. You might have seen stuff like this before, maybe. It kind of is the same as these guys. See, there's lots of hydrogens on here and stuff, so each one of these guys has hydrogens. Anyway, you don't really need to know all that, so we'll just kind of erase these things here. There's got to be a quicker way to erase that. Looking back here, what would I call this structure? Well, we had our peroiodates. We know that when they have their hydrogens, they become periodic acids. But what happens if they have hydrogens and carbons all bonded like that? Well, we would call this a periodic table. And you should be laughing at that right now if you understand anything to do with those acids. So hopefully that helped us with a little bit of acids and realize that, you know what, you can still have some fun when you're doing nomenclature.